So welcome back. I welcome you for this last session of this 2 days online workshop. And now in this session, we are going to have some hands-on training on how to perform an artificial neural network example for a given set of inputs and outputs. So this is the front GUI that when you open a MATLAB software, in this I am going to type NN tool, that is neural network tool. So if I press enter, then this neural network data manager, that is NN tool, will pop out. So we are going to do the model fitting only in this graphical user interface. But before going into, we have to segregate our data into 3 different types. Okay, that we will see initially, and then we can load. Okay, now in this Excel sheet, I have got my input and output data. So here I have got 30 experiments, the results, that these 4 in column B, column C, column D and column E are my input factors, and the corresponding output is listed in column F, column G and column H. So this is experiment carried out based on some design of experiments, and then I have recorded. In ANN, we should have 3 different files. One is the file for training the network. Okay. There should be some output file for supervised learning, and for third I should have a testing data, the input data for training. So these are the 3 files that I am going to formulate. These are the 3 files I am going to formulate. The first one is the input data for training the network, that is, from this I am going to select. Then output, the output that corresponds to these inputs, that is present in these columns, and then testing data. So initially I have to segregate the data from the available 30 experimental conditions. So randomly I am going to select. So I will make the selection in red colors. So I am going to select the experimental number 5. So this red color implies that I am going to use it for testing. Then 10. Randomly I am going to select. Then 16. Then 22. Then 26. 30. So randomly we can select. But what is the basic rule? If I am going to have $100 experiments, then 60 or 66 experiments, that is 2/3 of the experimental data should be used for training purpose, and 1/3 experimental data should be used for testing. That is, if I contain 30 experiments, then 20 experiments should be carried out should be segregated out for training the ANN network, and 10 data should be taken for testing purpose. But here we have taken only 5. The red 1, 2, 3, 4, 5, 6 data I have taken. So 24 data we have considered it for training purpose. The higher the number of data that we are going to select, a perfect model can be fitted. So now I have identified data that I am going to provide for training as well as testing data. Now I am going to remove the testing data from the set of experiments. So I'm going to just paste this. I'm going to just cut it and I'm going to just paste. That is, I'm segregating it. I'm segregating the data that I'm going to consider for the testing. So totally 6 data I'm going to consider. Now here we have some bracket. So that just delete this because my data should be continuous. Delete. That's all. So now here you can see how many data you have taken. Just select, and at the bottom you can see the count is 24. That is 24 experimental data are I am going to use it for the training purpose of the ANN model, and the remaining 6 we are going to use it for the count number you can see here 6. The 6 we are going to use it for the testing. So the same input and output I am going to give it to them. Now I have segregated. The next step is I have to transpose the matrix. That is, I have to transpose. Now I am going to select the. So this is my training data. Just select all these things, including the headers. Now select new sheet. Select new sheet and name it as transpose. Transpose to data. Now just right click here in any box and right click here in the fourth you can see the first one is paste, second one is values, third one is formulas, and fourth one you can see transpose. That is converting the rows into columns or columns into rows. So that I am going to do. Okay, so I am going to transpose this data. Okay. Similarly, this testing data should also be done the same category. Here I am going to transpose it. Fourth one, transpose. Okay. So now here we have done all these things now. Right. So the black colored numbers are my training and the red are for testing. Now I am going back to the MATLAB environment. Okay. Go click on the home tab. This is regulation 2000. Sorry, this is version R 2018 alpha. Okay. So now 2020 has arrived. Click the home button. In this, we can have new script, new live script, new, open, find, then import data, then save to workspace. So here you can see new variable, open variable, clear workspace. In this, I am going to click the new variable. So this will open. So on the left side, bottom, you can see workspace here. You can see workspace here. In this, you have a variable that is unnamed. Just right click that and rename it to, this is my training data. This is my training data. My training data, that is the input to my training is, so this is the run error. So just we have to omit this. This run errors and all these things we have to omit. Okay. So input. So these 4 are my inputs. These 4 are my inputs. I have to select only the inputs. Don't select the outputs. So I have selected only the inputs for training purpose. Now going back to MATLAB, just keep your cursor here and press Ctrl V, so that all the data will be pasted. Here you can see 24. Okay, so 24 data that I pasted, and that too, that is the input. So for this, I have to enter the corresponding output data, which we call it as the target data, because here we are going with supervised learning algorithm. Okay, then only a perfect prediction is possible. So same home. In this, I am going to add another variable. Here you can see new variable. Click it. It comes unnamed. On the left side, bottom workspace, I have training and unnamed. Just right click the unnamed and change it to target data. Okay. Now, what is my target? For this input, these are the outputs. These 24 are my outputs. For the 24 inputs, I have this 24 as my outputs. Now, right click and paste. So 24 data, kindly check how many data we have entered. It is 24. So for 24 inputs, I have to enter 24 outputs. So I have given the training data as well as the target data so that supervised learning is possible. Now another variable that I have to create is the testing data. Once a model is developed, I have to validate the model. Finally, I have to validate that model whether the model developed predicts well. For this only, we have taken that 6 readings separately. Okay, so the next variable that I am going to provide is, so I am going to right click this unnamed in the workspace. So right click, rename, that is my testing data. We call it as the testing data. Okay, in the testing data, I am going to provide these 6 values and that too only inputs. So only inputs I am going to provide and I am not going to use these outputs. I am just going to paste this. So I am going to just paste this. So these 3 outputs I am not going to use because the system will predict the output for these 6 inputs and that 6 outputs will be compared with these experimental results. Okay, so I have used these data in full. I have used the input data as well as the output data, that is for training purpose. So this is for testing the model. So I have to give only the inputs and the output should be predicted by the ANN model. So 3 you have the training, 4 into 24. So 4 inputs and 24 experimental readings. Here you can see 4 into 24 doubles. Target, once again 3 outputs but 24 values it should be there. And testing the 4 input variables and 6 readings. Now with this, here you can see the command window. Okay, here you can see the command window f of x, in which I am going to type neural network tool, NN2. I am going to type it as NN2. Now I am going to press enter so that this neural network data manager will pop out. Right? In this, on the left side we have the input data, target data, input delay states, and on the right side we have output data, error data, layer delay states, and all these things. And in the middle we have networks. There is no data here. We have to provide this data. Okay. Here at the bottom we have import new. Okay. Open, export, delete, help, and close. So import and new alone will be highlighted, where the other tabs are hidden. Click import. Here you can see source. Import from MATLAB workspace or import from disk file. The disk file is nothing but local storage system, C or D drive or E drive or something. Here we have select a variable and the destination where we are going to import. Okay. So in the MATLAB workspace at present, here you can see, if I am going to change it from MATLAB workspace to local disk, the variables that is present in the workspace that we have developed, target, testing, and training will not be highlighted. So I am going to import from MATLAB workspace. So these are the variables that I am going to have. Okay. Now my initial work is to develop a ANN model. For this I have to train a ANN model. So training data I have to select, and that is my input data. The model, then what I am going to give the input for the ANN is the training data. Select import. Variable training has been imported as input data into the network data manager. So now I have given variables x1, x2, x3, x4. Since we have selected 4 variables, in the input layer I am going to have 4 neurons. Okay, x1, x2, x3, x4. So what is the corresponding output for these 4 inputs? That is my target data. So now I am going to select the target. So here in the destination we can have the second checkbox, the target data. So target data, target, import. Variable target has been imported. Okay. Now finally I have to check the validity of the ANN model. So for this I have to test. So the test data is what I am going to give the input to the model, and the model will predict my output. So the testing data is also a input data. So select testing data and give it as the input data, import. Okay, just close it. Now on the left hand side, input data, you can see the training and testing. So both are inputs to the ANN model. Okay. Similarly, in the target data, you can see target, that is my output. So for the training data, this is my corresponding output. So I am going to with a supervised learning algorithm. Now you can see all these things are highlighted. All the tabs, open, export and delete tabs are highlighted. Now I am going to click this new. So all the workspace variables I have imported. Now I am going to develop a network model. New. I am going to press new. Once I will tell, I am going to press new. So here it will ask create a network or data. I am going to create a network. That is workshop. That is workshop. The name of the network is workshop, and network properties. So the network type, you can click this. So we have many types. So we have to select any one of these. But according to the literature surveys, this feed forward back propagation produces better results. Okay, but this will vary with different problems. For example, for a electrical problems, it may be different. Okay, for a communication problem, it may be cascade forward back propagation. Likewise, so what type of network that we have to choose will be decided based on the literature survey and by experience. We can also try with the various network type, and we can also write a comparison on. We can also make a comparison. But now I am sticking on with feed forward back propagation. Okay, that model that we have seen in the morning. So the input data, select an input, there will be 2. The first one will be training and the other one will be testing. Now I have not developed any ANN model, now only I am creating. So the first input that I have to give to the model is my training. So initially I have to give training, then only I can test. Without training I cannot test a model. So the first input is training data. So what is the corresponding output? That is the target. For training, the target is the target data. So don't give testing and target, because we have 24 experimental runs in training data. So 24 output should be there. If I am going to change this, then obviously model will not be, our network model will not be developed. So here you can see. So input data and target, that is input and output we have given. Now training function, we have this, the drop down box, we have train BFG. Training is train. BFG, what is BFG? Quasi-Newton method. Okay, back propagation quasi-Newton method. Similarly, BR. Similarly, CCB, CG. So CGF, we have conjugate back propagation, and CGF uses Fletcher-Rives update, whereas CGB, conjugate back propagation, okay, conjugate back propagation, which uses Powell-Bale update. So similarly, there are many models that is developed by several researchers that has been included in this. Okay, here we are going with learn GD, train GD, okay, train gradient descent, okay, and train GDM, gradient descent, momentum weight and bias function, train GDM, gradient descent. GD stands for gradient descent and M stands for momentum weight and bias function. Then we have GDA and X. So gradient descent adaptive. Okay. And the GDX with the back propagations. So appropriate training function we have to select. Now I have to stick on with train GDM. That is train gradient descent momentum weight and bias function. So automatically the weights will get attached. I am not going to provide any weights here. The system itself will take a random value. The system itself will take a random value and assigns the weight according to the output. So we are given a target, that is a supervised learning. So I want the desired value. So accordingly, because of back propagation, the system will automatically adjust the weight and bias, so that using the gradient descent method, the G should be equal to 0. That is, the slope should be equal to 0. When G is equal to 0 in the gradient descent method, obviously a perfect prediction is possible. Similarly, in the adaptation learning function, we have learn GDM and learn GD. Learn gradient descent and learn gradient descent method. I am going on with learn gradient descent, momentum weight and bias function. So training, and in the back propagation, I am going to learning phase using the gradient descent method. The performance function, I have these three. You can click the arrow mark so that the drop down menu will come. We have MSC. MSC is mean sum of error, and SSC is sum of squares error. Then MSC REG, that is mean squared error with regularization, mean squared error with regularization. So I am going to stick on with MSC. So I am going to stick on with MSC, mean squared error. So number of layers, first I will stick on with 2. Okay, now I am going to view. So input, 4 inputs and 3 outputs. Here I have only one hidden layer. Okay, but it is representing as 2. What is this? Hidden layer 1 and the output layer. Okay, if I am going to change this to 3, okay, I am going to change this to 3. Here you can see 3 layers now. Now I am going to view. So here you can see. So if I want to change this number 1, what I have to do? In layer 1, 10, and layer 2 is also 10. And layer 3, it is blocked because the layer 3 is the output layer. Okay, so layer 2, 10. Now I am going to view. So I have given 10, so it has changed. Increasing the number of hidden layers obviously increases the complexity and computational time of the developed model. So we have to find an optimal hidden layers and number of neurons in the hidden layer. So initially start with a single hidden layer. Then if I am after subsequent iterations, okay, if I am not satisfied with my results, then I can move with the second hidden layer. So likewise we have to do. So now I am going to stick on with the number of layers as 2. So now you can see layer 1 is highlighted and layer 2 is not highlighted. It is the output layer. The transfer function is the sigmoidal function. Log sigmoidal, pure linear. Pure LIN is pure linear and tan sigmoidal. I am sticking on with the tan sigmoidal function, which will provide a better function that varies between -21 to 1 or 0 to 1. Okay. Now I am going with create. So after giving all the properties of the model that I require, I am going to create new network called workshop added to the network data manager. Okay. Now I can close. That's all. Now in the network, we can see a name workshop. Okay, now double click that. That network will get open up. The first tab is view the network, second one is training, third one is simulate, then adapt, reinitialize weights, okay, then view edit weights. So everything we can see, but we are most important to this second one and third one. I am going to use this tab, train for training, and simulate is for simulating the results for a given set of testing parameters. So train, it has two tabs, training info and training parameters. First go with the training information. The input, I have not trained the network yet, so I have to go with the training. Don't go with testing because I have developed a network. So I have to first train the network. So training is my input and the corresponding output is the target. That's all. Okay. Now move on. So these are all the outputs that will be given. So this is the predicted outputs and the corresponding errors once we use the simulation. Now training parameters. Show window, true, show command line. No, don't show the command line, show epochs. Here we are interested in 4 things. The number of epochs, which is nothing but the number of iterations. Then maximum fail. The maximum fail is the same number of epochs. Okay, what happens when that is lower to the epoch value? That also we can see. Then we have LR, the learning rate, the momentum coefficient. The momentum coefficient should not be as high as possible or as low as possible. Okay, both these values will tend to vary in between zeros to 1. But you can change this according to the requirement so that a perfect model can be developed. During the process, we will change and see the results also. Now I am going to stay on with the maximum fail. Okay, my number of epochs is 1000 and maximum fail is 6. And these are my learning rate and momentum coefficient values. After providing these values, I am going to train the network. There is a button. Okay, tab, train network. Just to do this. Here you can see the network model developed and then algorithm. Training is, the data division is random. Okay, training, gradient descent with momentum, train GDM. Then performance, mean squared error. Epochs, 0 to 1000, but in the 13th iteration itself, it has stopped. Why? The computational time, 0 seconds. Then performance, 1.2, that is 0.805 and all these things. But check at the validation checks, 0 to 6, because I have not altered that 6. So once that validation checks reaches 6 iterations or 6 values, then it stops. That's why we have to provide the same number for iterations or epochs and validation checks. Okay, now we have the plots. 3 plots we have. The performance plot, the training state and the regression. Now click the performance plot. Here you can see it is not converging yet. It is not yet converging, the red. Okay, so still it needs best validation purpose 0.55. Okay, so still it has to go. Then training state. Here you can see it is not yet converged at all. It is not yet converged at all. Then regression. You can see 9799, but you can see a straight line is not fitted. There is random points. That is random data are available. So just to cancel this. Now I am going to give 1000 epochs. The same 1000 I am going to give it to the maximum fail. Now I am going to train the network. Now it is going. So the maximum time taken for this is 2 seconds. The maximum time taken is 2 seconds to reach that 1000 iterations or epochs. Now I am going to check the performance. This is somewhat okay. Then training state. So from this training state, we can see that the gradient, it has to move towards 0 or the slope should be 0. G is equal to 0, no? But there is a change. Still there is a change. So this graph, so see the cursor here, has not converged yet. So we have to wait until convergence. Since we are going to consider only 1000 epochs, this convergence is not possible. So we have to increase the epoch numbers. So see the regression plot. Here also you can see the R square value is good in all these cases, but here you can see a perfect straight line fit is not possible because of the formulated regression model is not perfect enough. So this I am not going to accept. The same thing we should not train again. That's the problem in this. The same thing I should not use. So I have to cut that. I have to delete. I have to delete the network. So once again I am going to develop a new network. Okay. I have to train. For each and every training purpose, use a new model. A model that provides the best results you have to take. Because the same model, whenever we are going to use or train, it will start from the last state. It will start from the last state. So that is not suggested. Okay, the workshop, feed forward, then training, then target, then train GDM, learn GDM, mean squared error, number of inputs is 2, tan sig model, and all these things create. Okay, so now double click and train. Input is training and target, training parameters. So here you have given the input and target, then training parameters 1000 epochs. Now I am going to change it to 5000 epochs. And maximum fail or validation checks the same number of epochs. The learning rate and the momentum coefficient I am not going to change. Now train. So the 5000 iterations has arrived for 10 seconds. The time taken is 10 seconds. So the computation time is 10 seconds. The performance I am going to check. Then training state I am going to check. So here you can see convergence has occurred. Convergence has occurred now because we have gone with higher number of epochs, that is iterations. Then regression state. So this is 0.99, but still some points are on both sides of the straight line fit. But when compared to the previous model, this is good. But we cannot accept this also because here you can see some points are distracted or away from the straight line. So don't use the same model. My suggestion is we have to develop a new model for each and every training. So what happens if I am going to change this? And then once again I am going to change. So this model will be in a better state than that of the initial stage. Now if you are going to train the same model, obviously it will start from the last position that it has attained. So for each and every network training, develop a new model. So what happens when I am going to change these values? So don't change the values for learning rate and momentum coefficient at the same time. Don't change the values of learning rate and momentum coefficient for at the same time. Once, if I'm going to change the value of learning rate, then keep the momentum coefficient as constant. If I'm going to change the momentum coefficient, keep the learning rate as constant. Now I have changed this. So train network. Now check the training state. Now there is a slope in this, so I cannot accept. So regression. So little bit it is improved. It is improved by little bit because in the previous case, here we have 0.97. Now it has been raised to 0.99, but still some points are not fitted properly. So for example, now I am going to change the momentum coefficient as 0.85. Actually, this should not be done. Actually, for each and every training, a new model has to be developed. Now here, for a hands-on training, I am using the same model. That should not be done. As this is for example, I am doing this. Check the training state. So still, it has to converge. So regression. So the same problem exists. So same problem exists. So more training is needed in this case. So what happens if the epochs is changed to 10,000? Similarly, the maximum fail, that is validation checks, is also changed to 10,000. Now check the training state. So now still there is something. Then regression, somewhat it has fitted. Somewhat it has fitted, but there is a problem in this validation and testing data. So I am going to stick on with that 0.9 or 0.95 I am going to change. Then I am going to train. See, the computational time is increasing. The computational time is increasing. Now, instead of 11 seconds, now it has taken 22 seconds. Check with the training state. Little bit it is converging, but still it is converging. In regression, you can see it is somewhat good than that of the previous ones. Right. Now I am satisfied with this. Okay. This performance, this training state we can copy, file, then we can save to workspace, or we can edit, and all these things we can do. Then regression we can copy and we can paste it in our manuscript. Then what we have to do now? I have developed a model now. Then I have to test that model, whether it is a valid model or not. Okay. Now in the top tab, view, train, simulate, we will be having a simulate option tab. In the simulation data, I am going to provide the inputs, whether I have to give training or testing. Now I have trained a model. At present, I am going to test that model. So I have to give testing. And the simulation results will be stored in outputs. Okay, workshop outputs, or we can give these values. Workshop AN, for example. Now here you can see a model here, that is simulate network. The network has been simulated and the results stored in the network data manager. Okay. Now I am going to cut this out. So here you can see that output data. Here I can see that output data. If I double click, this will be open. Okay, how to export that into the workspace? That is, like this I want to export. So just click that or select that workshop ANN. Here we have a fourth tab, import new, open, export and delete. In the fourth tab, export, just click export. Which I want to export? This workshop ANN. So workshop ANN, highlight that and click export. Variables have been exported to workspace. Close. Now on the left side workspace, here we can see target, testing and training that we have initially developed or created, and now here we have a workshop ANN. Just double click that. So 6 readings we have because we have provided 6 inputs. Okay. So now copy that. I am going to copy that and then I am going to paste it here, and then I am going to paste it here. That's all. So this is my experimental data and this is my predicted data. So this is my predicted data. This is experimental and this is predicted data. So how to compare? How to compare? Just select these two and insert scatter plot. So just like that we are going to have. Okay, sorry, it is not so. So here you can have. So this data insert. So here I am going with 2D lines. So now you can see this is series 1 is nothing but the experimental curve width, and the red is corresponds to the predicted curve width. So a nearby prediction is possible since I have not trained that much perfect. So now itself I am going to have some nearby predictions. Okay. So now I am going to draw it for surface roughness. Select these two values and insert, then lines. So here you can see somewhat perfect prediction is possible. The system itself is going to adjust the weightages and biases so that the gradient descent is going to come to 0. That is G is equal to 0. So this is how we are going to develop the model. Okay. Now in this case, now I am going to change, or now I am going to delete this. So delete this network model. Now I am going to develop a new one. The name is workshop. The network type feed forward. Then select an input, training. The corresponding output is target. Then train gradient descent with the momentum weight and bias function. Then learn gradient descent, momentum weight and bias function, mean squared error. Now I am going to change the number of input layer, hidden layers. Now I am going with 3. So 2 hidden layers and an output layer. Layer 1 it is 10. Layer 2 I am going with the 10s. Then view. So hidden layer 1, hidden layer 2 and the output layer. Here you can see the weightages. W stands for weight and B stands for B, bias. and here you can see the sigmoidal function, trans-sigmoidal function. So I'm going to change it to this. Here you can see the linear sigmoidal function and all these things. Okay. So layer 1 tan sigmoidal function I am going to select, and in the layer 2 log sigmoidal, that I am going to consider tan sigmoidal view. Here you can see that values, it varies from -1 to +1. Now layer 1 I am going to change it to log sigmoidal, and layer 2 I am going to change it to log sigmoidal. Here you can see the sigmoidal function changes between zeros to 1. Likewise, I can give different transfer functions. Or layer number 1 I am going with linear, and layer number 2 I am going with pure linear. So here you can see a linear function. But once we go with the sigmoidal function, then only accuracy will be higher. So once again I am going to change it to tan sigmoidal, and layer 2 tan sigmoidal. So now I am going to change this. So 2 hidden layers. What happens? The complexity increases now. So perfect prediction is possible. Now double click the workshop now. So second tab, train. The training info input is training. Target is my target. Then training parameters. The number of epochs I am going to give it as 10,000, and maximum fail the same value as that of the epoch, and the same learning rate and momentum coefficient I am going to use. Then train network. So here you can see the computational time has been increased by 5 seconds. Since it is a simple problem, it is lower time, computational time. When the complexity of the problem gets increased, the computational time will also be higher. So now I am going to check the performance. It is little good. The training has produced lowest mean squared error. So this is good. And training state, now it has converged. Now it has converged. So this is also good. Then regression, it is not good. Here you can see the data are not fitted perfectly. So again I have to train. But for this I have to develop another network. Because of time problems, I am going with the same networks. So train. Now regression. Now it is similar trend. So again I have to simulate. So now think that my training of this network is perfect. Now I want to simulate again. So simulate, in the third tab, simulate my input. I have to test the data now. So I am going to test the model now. So testing. Okay. Now simulate the network. That's all. The network has been simulated and the results are stored in the network data manager. Okay. Okay, then cut it out. So here the workshop outputs is my outputs. So just click export network outputs. You are going to export. Okay, close. So in the MATLAB front end, you can see the workshop outputs. Now I am going to place it here. Now here you can see The values are nearer. For Kerfith, it is perfect. For Kerfith, it is perfect now, little bit. But for these things, these two, surface roughness and MRR, it is not perfect. Why? Because the model is not perfectly fit. How you can see? From the R square value that we have obtained. From the R square value plot, the regression plot, what we have obtained, you can see whether all the points are staying on the or fitted by the straight line. And the R square value is 0.99. So based on this, we can develop a model in the ANN and we can simulate it and we can predict. So after prediction, I can store this. So this network I can store. Just click this, export, that is workshop. This is my model, export to the workspace. So now here you can see that model. So this is my workshop model, network. That I can store, save as something I can save, MATLAB. So I can store it here. So if I want to use this network, then I can call that. Then I can call that from them. So import, load disk from file, browse, desktop, MATLAB, workshop. So this is my load. Close. So now here we can have the workshop. That's all. So by this we can store the developed model that can be used for further predictions. But what is the range of inputs that we have provided? That alone should be given. If I am going to give you a value lower than the range selected or higher than the range selected, then obviously I will not be getting a perfect prediction. So with this, I come to the end of this training session. I hope that you have learned something how to perform a ANN in MATLAB environment. And I thank you all for this active participation in this 2 days workshop. And I wish you all grand success. If you have any doubts, kindly chat with me. I will be clarifying your doubts for the next few moments. Thank you.